so this is our honors chemistry lesson video for section 10.3, but this is only part 1. So in part 1, we're going to focus on something called percent composition or mass percent. So the percent by mass or the percent composition of an element in a compound is the number of grams of the element divided by the mass in grams of the compound multiplied by 100%. So that's a really wordy way of saying it's the element over the compound times 100 to turn it into a percentage. So this is the formula we're going to use. So the percent of the element is the mass of the element over the mass of the whole compound times 100. Okay, so we're just trying to figure out what part of the compound is a specific element. So it's kind of like if I was trying to figure out what the percentage of girls were in my class. I would take the number of girls, divide by the total number of students, and multiply by 100 to get my percentage. So the same thing's happening. We're going to do the mass of the element over the mass of the whole compound times 100. So let's look at some examples, because there's really two different ways that you'll do this. So the first type is I will give you the masses of the elements or the compound. And so you'll work with those. And then the second type I'll show you in a few minutes is when I don't give you any masses and you have to use the periodic table instead. So this says when a 13.6 gram sample of a compound, so I know I have the whole compound. So 13.6 gram sample of my compound containing only magnesium and oxygen, so I know it only has magnesium and oxygen, is decomposed, 5.4 grams of oxygen is obtained. So I know 5.4 grams of this is oxygen. What is the percent composition of the compound? Well, when you're doing percent composition, you need to know the mass of the whole compound and the mass of all the elements. So it says it only contains magnesium and oxygen. It gave me the whole compound and it gave me just the oxygen, but I'm missing how much magnesium I have. Well, since it told me it only has magnesium and oxygen, I can just subtract these two numbers to get my magnesium. And so once I subtract those, I get 8.2 grams of magnesium. Okay, so if you know the whole compound and just part of your elements, but you're missing one of the elements, you can just subtract to figure out your other element. Now for percent composition, unless it specifies which element it wants, you need to do this formula for each element in the problem. So in this case, I have some magnesium and I have some oxygen. Okay, so I'm just going to start with magnesium. So my percent of magnesium is mass of just the magnesium, so that's 8.2 grams, over the mass of the whole compound, which is 13.6 grams, and then times 100. So once I do that, I end up getting about 60.3. The unit, because grams will cancel, is percent, because technically we're multiplying it by 100%, and then you have to put which element you're talking about. So this compound is 60.3% magnesium by mass. Now we also have to do oxygen. Now if you're confident that you got magnesium right, and then there's only two elements, technically we can do 100 minus 60.3 to get oxygen, but I always like to do oxygen separately. So I'm actually going to plug it into the formula. And then, to catch any mistakes, I like to add my two answers to make sure that they equal 100. So that way I can check for any math errors. Okay, so now I'm going to do my percent of oxygen. So it's mass of the oxygen, which in this case was 5.4 grams. That's how much the question told me I had. Over mass of the whole compound, which was 13.6 grams, times 100. My grams canceled. And so when I solved, I got 39.7% oxygen. And so see, now because I did both problems separately, I can add my answers to make sure I get 100. Because the problem is, if you accidentally made a calculator error when you did magnesium, and then you just do 100 minus that, you're automatically going to miss oxygen too. If you made a calculator error when you do magnesium, and then you do oxygen, the way I did it, you'll see you don't get 100, and then that gives you a reason to go back and double check everything. So that's why I like to do it this way. However, if you're totally confident in your abilities, you're more than welcome to just do 100 minus your percentage to get your other one. Because I mean, that obviously will work too. All right, so let's look at a couple more. If you're ready to try one on your own, you're more than welcome to try this top one. Just pause it, but I'm going to assume you either tried it or you're waiting on me to do it, and you're going to try this one at the bottom. All right, so it says when a compound formed when 9.03 grams of magnesium, so we know we have 9.03 grams of magnesium, combines completely with 3.48 grams of nitrogen, what is the percent composition of this compound? Okay, so we have a compound that was formed with just magnesium and nitrogen. We know how much magnesium, we know how much nitrogen, and the problem is we don't know the mass of the whole compound. Well, if you have both elements, you just add them together to get the compound. So I can add these two numbers together, and once I do that, I get 12.51 grams of the whole compound. Okay, so see in the previous example, it gave me the whole compound, but I was missing one of my elements, so I could subtract the other element from the compound. This one, they gave me both elements, but I was missing the whole compound, so I just add them together to get it. Okay, so again, I have two elements, so I need to use this formula twice, one for magnesium and one for nitrogen. So I'm going to do magnesium first. So my percent of magnesium is the mass of magnesium, which is 9.03, divided by the mass of the whole compound, which is 12.51. And then times 100 to make it a percentage. So my grams cancel, and so once I solve, I end up getting 72.2% magnesium. Okay, and make sure you put your element, number, unit, substance. Okay, don't just put 72.2%. All right, and so then I need to do one for nitrogen. So my percentage of nitrogen is mass of the nitrogen, which is 3.48 grams of nitrogen, over mass of the whole compound, which is 12.51 grams, times 100. Those grams cancel, and so once I solve, I got 27.8% nitrogen. And then I can double check my answer by adding these two and see that I get 100. Now, due to rounding purposes, sometimes you might not get exactly 100. Like if you get 100.04 or 99.97, that's fine. That's probably a rounding issue. But if you're getting something like 75% in total, then obviously there's something wrong there. If you're getting 123%, there's something wrong there. So you should be getting incredibly close to 100. All right, so pause the video and try this one. I'll assume you've done that, and now we'll try it together. So it says, when a 14.2 gram sample of mercury 2 oxide. So this time it gave me the name of the compound. Now I know this is a compound because it has mercury and oxygen. It's mercury 2 oxide, so that's a compound. So I have 14.2 grams of my whole compound. Ooh, I hope y'all can see this down here. It's decomposed into its elements, and I can clearly see it contains mercury and oxygen, so two elements. By heating, 13.2 grams of mercury is obtained. Mercury is Hg, by the way. Hopefully you already knew that. So I got 13.2 grams of mercury. What's the percent composition? Well, I know this compound also contains oxygen because it's called mercury 2 oxide, so I need to figure out oxygen by subtracting. So if I take my whole compound and subtract the 13.2 grams of mercury, I get 1 gram of oxygen. So now I know this compound is 13.2 grams of mercury, 1 gram of oxygen. So now I'm ready to use my formula. So I'm going to kind of move over a little bit so that hopefully y'all can see a little better. So I'm going to start with mercury. So my percent of mercury is mass of just the mercury, which is 13.2 grams, over mass of the whole compound, which is 14.2 grams, times 100 to make it a percent. My grams cancel, and so I got about 93% for mercury, so 93% Hg. So obviously I can tell that oxygen should be about 7%, but I'm going to go ahead and plug it in just to make sure. All right, so here, I'll just kind of move up here for this one. So my percent of oxygen is my mass of just my oxygen, which in this case is just 1 gram, over mass of the whole compound, which is 14.2 grams, times 100 to make it a percentage. So my grams cancel, And so when I solved, I ended up with about 7%, which makes sense because 93 and 7 makes 100. Okay, so like I said, I always prefer to do it as 2 separate steps so that then I can check my answer instead of just assume I got the first one right and then just do 100 minus. But it's completely up to you on how you do it. All right, so this is how you do a percent composition or percent by mass problem if I give you the numbers. So see, notice in all my questions so far, I've been giving you the masses. Well, sometimes I won't do that. So if a percent composition problem does not give you the exact masses of the element, then you use the periodic table and you pull the molar masses instead. You use the same formula that we just did, except now you have to use the periodic table. Now the thing is, y'all, you shouldn't combine these two. Like if I give you masses, only use my masses. Like notice for the elements I was missing, I didn't use the periodic table, I would subtract or add or something like that. But if you don't see any masses, then you use the periodic table. So a question where you don't see masses will look like this. It just says, calculate the percent composition of propane, which is C3H8. So in this case, notice I gave you no masses. So remember, to solve these problems, we need the masses of the elements and the mass of the whole compound. So the first thing I'm going to do is just add up the molar mass. So C on the periodic table is 12, and remember the mass is the bottom number on the periodic table. But I'm going to multiply it by 3 since there are 3 of them. Hydrogen is 1, but I'm going to multiply it by 8 since there are 8 of them. And so when I do that, I end up getting about 44 grams per mole. So now I have each of my elements and I have my whole compound, so I'm ready to start. This formula has 2 elements, and just to let y'all know, it doesn't have to only have 2. Okay, it's just the ones I've been showing you so far do. So I'm going to do 1 for carbon. So my percent for carbon is mass of just carbon. Now this is where you got to be careful. I have 12 for carbon, but I have 3 carbons. You have to take into account how many you have. So for my mass for carbon, I'm going to put in 36 grams per mole for carbon. I'm not going to put in 12. It would only be 12 if it was just 1 carbon. And that's the part people forget to do. Alright, so then I'm going to divide it by the whole compound, which is 44 grams per mole. And notice I've just switched to grams per mole instead of grams because now I'm using molar mass. And molar mass has the unit of grams per mole. And then I multiply by 100 to get a percentage. So my grams per mole cancel. And so once I solve, I get 81.8% carbon. So see, these are the ones where you want to be super careful and don't then do 100 minus to get the other one. Because if you forget to multiply by the 3, when you try to add your 2 values at the end, you're not going to get 100%. And it'll remind you like, oh gosh, I did something wrong. And then maybe you'll figure out what it was. Alright, so I'm now going to do hydrogen. So remember, it's mass of just the hydrogen. So again, hydrogen 1, but I have 8 of them. So I'm going to put 8 grams per mole for hydrogen over mass of the whole compound, which is 44, and then times 100 to make it a percentage. So those grams per mole cancel again, and so for hydrogen, I ended up getting about 18.2% for hydrogen. And then again, you can see that when I add them together, I get 100%. Okay, so this is how you do it if you are not given any masses. You pull the molar masses from the periodic table. All right, so let's look at a couple more. All right, if you're feeling confident, you can try the next one. I will show you, though, that one thing that confuses people is I don't usually give you the formula. So if you write the formula incorrectly, you're going to calculate percent composition incorrectly. So again, if you struggle with writing formulas, you need to go back to Chapter 7 and Chapter 9. I cannot stress enough how much not being able to write a formula is going to keep biting you throughout the rest of this year. So it says calculate the percent composition of the sodium, hydrogen, sulfate. Boy, I gave myself a super long one. All right, so first I need to write the formula. So sodium is Na. It has a positive 1 charge. Hydrogen sulfate is a polyatomic ion. It is HSO4 with a negative 1 charge. That will be on your polyatomic ion sheet, which should be in your mind. Since it's a positive 1 and a negative 1, I don't need need to remember to cross charges. However, the downside is, look how many elements there are. I'm going to have to do 4 problems in one, because you can't keep a polyatomic ion together. Each element is separate, so I have to do 1 for Na, 1 for H, 1 for S, and 1 for O. All right, so let's go ahead and add up the mass. So Na is about 23, H is about 1, S is about 32, and O is about 16, but I'm going to multiply it by 4 because I have 4 O's. So when I do all that, I get about 120 grams per mole, so that's my whole compound. And so now I'm ready to start. So I'm going to go 1 element at a time, and I got 4 elements to do. So y'all, if you don't get it after you watch me do this long one, then I don't know what to tell you. All right, so we have percent of sodium. Let's just start with Na. All right, so it's mass of the element, which for sodium I have 23 grams per mole, over the mass of the whole compound, which is 120 grams per mole. I multiply by 100 to get a percentage. My grams per mole cancel, and for sodium I ended up getting about 19.2% Na. Now in this case you can't just do 100 minus, because we have 4 elements to get through. Alright, so next I'm going to move on to H. So I'll just throw H right here. So my percent for hydrogen is mass of the element. Well, for hydrogen I just have 1. So 1 gram per mole for hydrogen, over mass of the whole compound, which in this case is 120 grams per mole. I'm going to multiply by 100 to get a percentage. My grams per mole cancel. So once I solve for hydrogen, I get 0.83% for hydrogen. Which makes sense. It's 1 gram out of 120. That's less than 1%. Alright, so next I'll move on to S. So my percent for sulfur is, of course, mass of the element. For sulfur, it has a mass of 32. So 32 grams per mole for sulfur, over mass of the whole compound, which we decided was 120, times 100 to make it a percentage. My grams per mole cancel. And so once I solve for sulfur, I ended up getting about 26.7% for sulfur. Whew, that brings us to our last element, which is oxygen. All right, so, oh gosh, I don't even know where to write it. I'll just kind of put it up here. So my percent of oxygen is, of course, the mass of the element, and this is where you got to be careful. Yes, oxygen is 16, but I have 4 of them. So I'm not going to put in 16 for my mass for oxygen. I'm going to put in 64, because that's 16 times 4. So I have 64 grams of oxygen. And to see if you forgot and put in 16, when you add your 4 amounts, you will not get 100%. So that's a way to catch those errors. All right, over the mass of the whole compound, which is 120, and then times 100 to make it a percentage. Whoops, oh sorry, I forgot grams per mole on the top. I'm trying to write super small so I can fit it all on here. All right, so for oxygen, I solved and I ended up getting about 53.3% oxygen. And so remember, y'all, I need number, unit, substance. I don't want to see 19.2%. Because I don't know, are you talking about sodium, sulfur, hydrogen, oxygen? Did you even get the formula right and you have any of those correct? So you got to tell me what the substance is. All right, so if you haven't tried one on your own, try the next one. I will tell you for this one, I cut us some slack since I just had to do 4. And you only need to do the percent of nitrogen. So I don't care about the other elements unless you just want to do them. All right, but make sure you write the formula correctly, ammonium nitrate. So pause the video, try it, I'll assume you've done that, and let's look at it together. So it says calculate the percent composition of just nitrogen in ammonium nitrate. So in this case, I don't have to do each element. I can just do nitrogen. All right, so first let's write our formula. So ammonium is NH4 positive 1. That's a polyatomic ion on your polyatomic ion sheet. Nitrate is NO3 minus 1. So that is also a polyatomic ion. So positive 1, negative 1 cancel, so I don't need any extra subscripts. So first let me go ahead and add up the masses. So nitrogen is 14. Hydrogen is 1. I'm going to multiply it by 4. Nitrogen is 14. Oxygen is 16. And I'm going to multiply it by 3. So once I do all that, I get about 80 grams per mole. Now, normally I would need to do nitrogen, hydrogen, and oxygen. I would have to do 3 problems. But because it just specifies nitrogen, that's the only one I have to worry about. All right, so my percent of nitrogen is the mass of the element. Now this is where you gotta be careful. Nitrogen is in more than one spot, so I don't just have 14 grams of nitrogen, I actually have 28 because there's two nitrogens. It doesn't matter if they're split up. You can combine them together. So I have 28 grams per mole for nitrogen, since there's two of them. And then my whole compound is 80. And then I multiply by 100 to get a percentage. My grams per mole cancel, and so once I solve, I get about 35% nitrogen. So see, on this one, I didn't need to waste time going back and doing hydrogen or oxygen because it just asked for nitrogen. So that was convenient. All right, so make sure that you realize from this lesson video that this is our formula for percent composition, also known as percent by mass or mass percent. And so if I give you the masses like in the first examples, you use those. But if I ask for percent composition and I don't give you masses, that's when you use the periodic table.